I'm Al Gore. I used to be the next president of the United States of America.
Former Vice President Al Gore's emotional film, An Inconvenient Truth, is regarded by many as the definitive popular presentation of the theory of man-made global warming. His argument rests on one all-important piece of evidence taken from ice core surveys in which scientists drill deep into the ice to look back into Earth's climate history hundreds of thousands of years. The first ice core survey took place in Vostok in the Antarctic. What it found, as Al Gore correctly points out, was a clear correlation between carbon dioxide and temperature.
We're going back in time now, 650,000 years. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, did they ever fit together? Most ridiculous thing I've ever heard. The relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer.
Al Gore says the relationship between temperature and CO2 is complicated, but he doesn't say what those complications are. In fact, there was something very important in the ice core data that he failed to mention. Professor Ian Clark is a leading Arctic paleoclimatologist who looks back into the Earth's temperature record tens of millions of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice we liberate, and then we look at the CO2 content.
Professor Clark and others have indeed discovered, as Al Gore says, a link between carbon dioxide and temperature. But what Al Gore doesn't say is that the link is the wrong way round.
So here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then, after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
CO2 clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes.
The ice core record goes to the very heart of the problem we have here. They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
But how can it be that higher temperatures lead to more CO2 in the atmosphere? To understand this, we must first restate the obvious point that carbon dioxide is a natural gas produced by all living things.
Few things annoy me more than to hear people talking about carbon dioxide as being a pollutant. You're made of carbon dioxide. I'm made of carbon dioxide. Carbon dioxide is how living things grow.
What's more, humans are not the main source of carbon dioxide.
Humans produce a small fraction in the single digits percentage-wise of the CO2 that is produced in the atmosphere.
Volcanoes produce more CO2 each year than all the factories and cars and planes and other sources of man-made carbon dioxide put together. More still comes from animals and bacteria, which produce about 150 gigatons of CO2 each year, compared to a mere 6.5 gigatons from humans. An even larger source of CO2 is dying vegetation, from falling leaves, for example, in the autumn. But the biggest source of CO2 by far is the oceans. All models assume that man-made CO2 is the main cause of climate change, rather than the sun or the clouds.
The analogy I use is like my car's not running very well. So I'm going to ignore the engine, which is the sun, and I'm going to ignore the transmission, which is the water vapor, and I'm going to look at one nut on the right rear wheel, which is the human-produced CO2. The science is that bad.
If you haven't understood the climate system, if you haven't understood all the components, the cosmic rays, the solar, the CO2, the water vapor, the clouds, and put it all together, if you haven't got all that, then your model isn't worth anything.
So the warmer the oceans, the more carbon dioxide they produce, and the cooler they are, the more they suck in. But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea? The reason is that oceans are so big and so deep, they take literally hundreds of years to warm up and cool down. The current warming began long before people had cars or electric lights. In the past 150 years, the temperature has risen just over half a degree Celsius. But most of that rise occurred before 1940. Since that time, the temperature has fallen for 4 decades and risen for 3. There is no evidence at all from Earth's long climate history that carbon dioxide has ever determined global temperatures. But if CO2 doesn't drive Earth's climate, what does? The common belief that carbon dioxide is driving climate change is at odds with much of the available scientific data. Data from weather balloons and satellites, from ice core surveys, and from the historical temperature records. But if CO2 isn't driving climate, what is? In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. How powerful this effect was became clear only recently, when an astrophysicist, Professor Nir Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun.
If you had X-ray eyes, what appears as a nice, friendly yellow ball would appear like a raging tiger. The sun is an incredibly violent beast, and it's throwing out great explosions and puffs of gas. An endless solar wind that's forever rushing past the Earth. We're in a certain sense, inside the atmosphere of the Sun. The intensity of its magnetic field more than doubled during the 20th century.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected, but now look again at the temperature record and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.